Let's now take a look at how we might find the equation of quadratics if we know the vertex of our quadratic and one other point. Now that point can be any point, doesn't have to be the y-intercept, but here we can see that the vertex occurs right on the x-axis here at the coordinate 2, 0, and our other point that we know is the y-intercept at 8. So when we've got this information here, we're going to put this into vertex form, and that is to say that we're going to put it in the form of y equals a x minus h all squared plus k, where our vertex is going to be the hk. And because we're subtracting the h, it means it's the opposite sign of our h, of our x coordinate, but the same sign of our y coordinate. Now in this situation here, our vertex is equal to 2, 0. So when we substitute this information now into it, we've got y equals a, x minus my 2, because it's got to be the opposite sign of my x coordinate, all squared, and then plus 0. And because I'm plussing 0, I'm not going to include it here. So now I've got this situation where I know everything except for this a value. So that's where I need to now use another coordinate to be able to determine what my a value is. Now I know that when my x is 0, my y has got to be equal to 8 from that coordinate here. So when my x is equal to 0, my y has got to equal 8. And I substitute those values back into here. So my 8 now has to equal a 0 take 2 is going to be negative 2 all squared. So now I'll solve for my a. So when I simplify this, this will be positive 4a. So therefore my a is going to be equal to 2. Once I've found my a, I'll just substitute that back into here, and I've found the equation that represents this quadratic that I've got on my graph. So therefore my y will be equal to 2x minus 2 all squared. And that is the equation for my quadratic on the right here. But let's now have a look at another example of this. So in this example here, we've got our vertex and we've got another point. So we're still going to use the same sort of process that we did last time. And that is to start by putting it into vertex form. So that is our y equals a x minus h all squared plus k. So now our vertex is negative 4, 2. Keep in mind we've got to change the sign of the x coordinate of that. So when we substitute that in, our y is equal to x plus 4, because that's the opposite sign of negative 4, and then keep the same sign of the y, so that's plus 2, and that needs to be all squared. From here, I now need to determine what the a value is, and to do that I need to substitute another coordinate other than the vertex that I know. In this case, I know that when x is negative 2, our y is going to equal 0 because it's the x-intercept. So I substitute these in. Our y is going to be equal to 0 when our x is equal to negative 2. So from here, I need to simplify this down. So our 0 will equal negative 2 plus 4 is going to be positive 2. 2 squared is 4. So it'll be 4a plus 2. Now when I subtract 2 from both sides, negative 2 will equal 4a. So therefore our a is going to be negative 2 on 4, or negative a half. Once we've determined our a, we've determined essentially our whole function here. So we just substitute our a back into the function here. So therefore our function in this quadratic is y equals negative a half x plus 4 all squared plus 2. So the key steps here, if we know the vertex and we know a third coordinate, what we do is we represent this in vertex form. So essentially we substitute the vertex in as h and k. Keep in mind we need to change the sign of the h, keep the sign of our k, of our vertex. And then from here we need to determine our value of a. To do that, you substitute the other coordinate that you know into the equation and solve for a. Once you've found that, you've then found the whole equation that represents this quadratic.